Without the ability to machine parts with precision, the modern society that we now live would not have been possible. Extremely hard, high melting, and durable materials are needed to make all the parts that this world needs. One of the most common and effective materials is tungsten carbide. Tungsten carbide is a member of a group called refractory metal compounds, which are all characterized by high hardness, elastic stiffness, and desirable electric and thermal properties. Tungsten carbide, or WC, is atomically composed of 50% carbon and 50% tungsten, making it an ordered alloy. This phase is a line compound. Tungsten carbide has a simple hexagonal structure where the tungsten is located on the nodes of the lattice and the carbon atoms occupy the 1/2, 2/3, 1/2 positions. This creates a mesh-like structure of carbon and tungsten characterized by strong metallic covalent bonds. This structure is responsible for its high melting temperature at 2600 degrees Celsius, a hardness of 9 on the Mohs scale, and high breaking ductility. The size of the crystal as well as the shape of the grain boundaries can be modified to suit more specific application. Two grain boundaries exist: twist grain and asymmetric tilt boundaries. Tungsten can be mined in the form of scheelite and wolframite, with the biggest deposits found in China. Using a series of complex impurity removing steps, including milling and sintering, tungsten powder can be extracted. After this, carbon black is then mixed with the tungsten powder and heated to temperatures between 1400 and 1800 degrees Celsius. This allows the energy necessary for the carbon atoms to diffuse into the tungsten in a timely manner. Tungsten carbide powder is now created. In its current form, it is very brittle and contains carbon and tungsten dislocations in the form of vacancies due to the manufacturing process, thus reducing strength and usability. The tungsten carbide is then bound into the surface of other metals, especially cobalt. The cobalt will fill any vacancies and restore strength to the tungsten carbide, as the tungsten carbide provides an extremely hard and resistant coating. Tungsten carbide has many industrial applications. This would include the cutting heads for machining and mining, which produce many of the products used every day in modern society. It is also found in armor-piercing munitions, snow tire studs, surgical instruments like forceps and hemostats, and is often the ballpoint many of the pens you probably use every day.